Very good evening, guys. Very good evening from Cheenta Statistics and Analytics Department, and we are yet live with today's problem for your preparation, helping your preparation right ISI MStat and IIT Jam for the next year. So today's problem is based upon it's a very well-known problem, in fact, but uh, the reason why I sort of decided to do this problem is the following: that so one of my students asked something very fundamental about this question, okay, and I will go toward into it towards the end after discussing the solution. uh, but that is very important, that idea is very important. So someone asked about really fundamentally about why we cannot differentiate to find the maximum. So here it's the asking, like, among the it's among the PMF of all the values of the PMF, like probability x is equal to x for all the values of binomial till n 0 to n. We are seeing all the probability, and we have to find for which x the probability is maximized, okay. And this is a solution. It's a well-known problem, but we cannot apply, like, to find a maximum we cannot apply differentiation over here, okay. There's a reason to that. But the student asked me, like, but to find the maximum of the log likelihood, or the likelihood, we differentiate now. So what is the fundamental difference between that? So I decided to make this video so that I can clear her doubt, and also I can solve this problem together. Okay, so let's get started with the problem right away. And also, if you have not solved the problem, please pause the video and like solve it yourself and then come back. Okay, so let's start the problem discussion. How do we do it? So first of all, let's check why this is valid. So if you see the various p and n, for fixing n, if you vary p, you see that for certain values of p, k, not p, for certain values of k, n is equal to like for certain values of k it is maximized. Okay, so we need to find that what are those k's. You can understand that k is something in between, like it's a maximum of all that, and we will see what is the number. Okay, we will prove that mathematically. It's a very easy to do proof, but you can understand one mathematical idea you should understand. This is the reason why you should always do exploratory analysis or draw graphs, is that you see that it's initially increasing and then it's decreasing. So there is some sweet spot before which there is initially increasing and after which it's decreasing. So it urges us to see the value. So it's like sort of forces us to see the value, that what is this value of probability. Let's call probability x is equal to k plus 1 is equal to pk plus 1. So therefore x probability x is equal to k is equal to pk, right? So we'll see that we are seeing that as a k is increasing till certain point, it's all pk are increasing, pk's are increasing, right? So therefore and then it's decreasing. So what's happening, that let's try to see the ratio of pk plus 1 by pk. So it's like this will be greater than 0, that is increasing till certain point, and after that pk will be decreasing, so it will be less than 1. pk's will be decreasing. That is what exactly is happening, right? So this is a very interesting problem solving strategy to like do it. How to find the maximum? You have to find the sweet spot before which it's increasing and after which it's decreasing, and that is the mathematics of it. Pk plus 1 by pk is greater than 1, that is it's increasing till this k is less than or equal to something, and then it's decreasing till k after k greater than something. What is that point? So we'll find that. So let's find that. So we have to find the ratio probability x is equal to k plus 1 by probability x is equal to k, and k plus 1 for n and p fixed, it's n choose k plus 1. So n choose k plus 1, p to the power k plus 1 into 1 minus p whole to the power n minus k minus 1 by, there's an extra this over here, yeah, by n choose k, p to the power k into 1 minus p whole to the power n minus k. So these are the pk plus 1 by pk minus by pk, okay, pk plus 1 by pk. And if we just cancel this out, you get p over here, and if you cancel this out, you get 1 minus p over here, And let's expand this. You see that it's expand you if into in let's expand that now. N factorial by k plus 1 factorial by n minus k minus 1 factorial into p by n factorial by k factorial into n minus k factorial into 1 minus p. So n factorial get cancelled, and we get sort of k plus 1, k plus, this get cancelled to get k plus 1 over here, and this gets cancelled to get n minus k over here. So we get that k plus 1 niche hai. So we get that n minus k into p by k plus 1 into 1 minus p. This is what we get, right? This is exactly what we get. Let me just check. Did I do something wrong? Or it's fine? I think it's fine, I guess. N minus I did some mistake or what? Just give me a minute. N minus k is upper. Is I think it's correct. Okay, I think it's correct. So let's try to understand this now. Yeah, perfect. Okay, so let's try to understand this now, that when this number is getting larger and when this number is getting smaller. Okay, so we need to understand that. So pk, let's see that we have got pk plus 1 by pk is equal to n minus k into p by k plus 1 into 1 minus p. This is, let's say, when this is greater than 1. So this is greater than 1 if greater than equal to 1 if and only if np minus kp is greater than equal to k plus 1 minus kp minus p. So I'm just expanding it. So it's turned out minus kp gets cancelled. So it turns out it's if and only if p into n plus 1 greater than equal to k plus 1. So it's if and only if I'm doing something wrong. No, it's fine. So it's greater than equal to k less than equal to np plus p minus 1. This is the idea. Okay, and let's see when it's less than equal to 1. So it will of course be less than equal to 1 if and only if k is just reverse. It will be reverse, greater than equal to np plus p minus 1. Okay, so we have got that. I think I have done the calculation correctly. In choose k plus 1 n factorial by k plus 1 factorial by n minus k minus 1 factorial, and this is less. So I think I have done it correctly. N factorial, it's get cancelled. Yeah, it goes upper, it goes niche, and 1 minus p is more over here. P is, yeah, I think it's correct. So therefore we have got that pk plus 1 by pk is greater than 1 if k is less than equal to less than np plus p minus 1. Yes, np plus p minus 1, and it's less than 1 if and only if k is greater than np plus p minus 1. So this is a basic idea, and therefore we have got that therefore it's increasing. So it's increasing. Pk plus 1 is greater than if till k is less than equal to this value. K is less than np plus p minus 1, and उसके बाद से is decreasing. So therefore you can understand that if by taking various cases like various values when n plus p is equal to 1, n plus p minus 1, once again. Yeah, so when you get that, what you get that before this value is increasing and therefore after this value is decreasing. Okay. Why I've kept a region over here is because k is an integer over here. So you have to understand for whether if this is an integer k, then it's a different value. If it's not an integer, then it's a different value. So after this point of time, what happens is that like this is the portion where it gets maximum. Okay. So if this is the if np plus p minus 1 is an integer, so k is equal to that value. If it's not an integer, then you have to check what happens in the integer just before that and just happens in the integer just after that, and you have to compare those. Okay, and those you have to compare those and then find out out of that which will be maximum. Okay, and that is the basic idea. And if you put, let's say, for example, if you put np, yeah, I think this is correct. Yeah, so that's it. So this is the basic idea, and this is how you find out. So you can put out values to n and p, and you can find out. Let's say it turns out to be, let's say 13.3, and it turns out to be this. So you calculate what happens till at 13, and you calculate what happens at 14, and then compare which is maximum. Okay, and that is the where it's happening, and maximum is happening. Okay. And also you can compare if np plus p minus 1 is an integer, you can also put that will be the maximum value. Okay, if it's an integer, if it's not, then you have to check the now integer just after that and before that and compare the probability at that point to find the maximum value. So this is a basic idea to understand. I don't know, but I may have done some calculation mistakes, I'm not sure, but I don't think I have done that. So this is a basic idea. So now this was a very straightforward problem. I think this is really done in the colleges, every single college. But the question is that the question the student have asked me is that why? The question student have asked me is why we are not differentiating over here, but why we're differentiating maximum likelihood estimator. Understanding maximum likelihood estimator, what we do is that we find the likelihood. And likelihood is a function of the parameter p. It's a function of the parameter p. P is the parameter p. It's a continuous random variable. It's a continuous between 0 and 1. While the probability here, it's varying over x is equal to small x. X is equal to small x. This is a discrete random, like 0, 1, 2 ऐसा जा रहे. So here we can differentiate it to find the maximum probability. But here we cannot differentiate it because the range on which we are seeing the function, we're trying to find the maximum of the function, the range in likelihood, it's a continuous, like an interval. Okay, but in this probability case, it's a discrete set. So we cannot take maximization by taking the using the rules of calculus. Okay, that's it. So that's a beautiful idea. That's a beautiful, interesting question. It's a very fundamental question. You should keep asking this sort of questions. Otherwise, you will not grow intellectually yourself. So this is very good. And perfect. So this is the basic idea, and you have understood how we have maximized it. And in fact, for any discrete random variable, this is the way it's done. It's called recurrence relation. So we find out the recurrence relation of the probabilities. Recurrence relation of the probabilities. And you can also try out as a homework on the same idea for Poincare random variable. For Poincare, you can try it out. And you can also see similar type of behavior because binomial converges to Poincare in some sense. So you try it out for Poincare, guys, and all the best. And I hope you enjoy the problem. And perfect. So I will see you in the next video. If you're liking this solving a day problem, do like, share, and subscribe with your friends who are preparing for the whole thing. And all the best, guys. And if you're looking for some crash courses, do not forget to check out the links below for the crash courses for IIT Jam 2022. All the best, guys, and keep solving problems every day. And a very good night to you from Cheenta Statistics Analytics Department. Bye-bye. All the best. Stay tuned and stay blessed.